Hello everyone, am I audible?
Yes, Sudhanshu, you are audible.
Okay, fine, so let's start. Okay, so first of all, I will go to your dashboard. So sorry, like yesterday, so I was not keeping well. So that's the reason. So I just canceled my class in the last moment, I think, after sending you a meeting invite. But today, so we will continue with the class. So all the recordings are, I think, already uploaded. So till last class, I'm assuming that all of you are going to join a Python class that we are trying to give in between weekdays, Monday, Wednesday, and Friday. And all of you are enjoying that class as well. Those who don't want to attend those classes, for them, pre-recorded videos are already available in all of your Python section. So we have uploaded it, and you can try to go through this. So in that section, so we will be talking about this entire Python module till, I would say, like a project. So till project part, so I will be talking about all of those things for sure. Soon I'm going to organize a separate statistics class, and what I feel is like whatever topics I have mentioned is more than enough to get a knowledge into statistics. But recently, so I have added a couple of more topics into my statistics module, so I will discuss that as well, but there will be a separate class for that. That will not be part of your regular lecture. Now, REST API Python project, so these are the things that we are going to discuss for sure in your Python class itself, so those who are reading this class now. So whatever classes that we have taken till last, so yes, code slide that we have used, so that is available over here. And apart from that, so whatever lectures I have given, so that is available over here. Now the next thing that we were supposed to discuss, or we were supposed to talk about, is like TensorFlow or PyTorch or neural network. So I have made all those recordings, a previous class recording, available over here as well. So most of the recordings and most of the code, so you will be able to find out that it's available. So code is available even in your computer vision module. For whatever module, if I find out that code is not available, so I'll just ask my team to update that module as well. As far as this NLP is concerned, so we have already uploaded all the code, all the assignments in every section. And yeah, so last class I was talking about basically like NLP overview or history of a NLP. This is what I have discussed in last class for sure. So and again, so we have started discussing about a learning. So when we say like a system is trying to learn, so what is a meaning of a learning in general? And when I say like, okay, system is going to learn something, so what is the exact thing which happens in a background, I would say. So in today's class, I will be talking about a neural network. So after completion of this class, NLP overview class, I will be talking about a neural network. What is a basic building block of a neural network, or how neural network learns? Last time I was talking about y is equal to mx plus c. So I was giving you entire references, learning references, just with respect to one single equation, which is nothing but it's a basic linear equation, I would say, y is equal to mx plus c, where I was trying to learn a parameter called as m and c, slope and intercept. I was trying to learn by doing a gradient descent approach. Now here in neural network learning, many things will come into a picture, and you should know each and everything bit by bit, mathematically as well as in terms of a architecture, so that you will be able to understand each and everything on all the complex module into a neural network architecture and all the papers. So just before your class, I was discussing about the papers like this kind of architecture, a different kind of a papers I was talking about, so that you will be able to understand the actual architecture. These are the architecture, these are the complex architecture. You will be able to unwrap and you will be able to understand into a best possible way. So keeping these things in mind, so we will try to start with a neural network learning. So fine, let's try to understand it. I'm going to share a blank sheet. So I think this blank sheet is available, or blank sheet is visible to you, right? Virat, Paul, anyone who can say yes, no?
Yes,
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 it is
it is
visible.
available.
Okay, fine. So here the last time, so I was like talking about, I would say, so I discussed about, I can say, y is equal to mx plus c, and we have seen that like how learning actually happens in that particular situation. So y is equal to mx plus c, where I was trying to learn a parameter called as m, and I was trying to learn a parameter called as c with respect to errors based on the gradient descent approach, I would say, into all the coordinates. So basically, I was trying to do a d by dm. I was trying to explain you, or d by dc. I was trying to explain you. I have not shown you a mathematical expression for this d by dm and d by dc. For sure, I will talk about that. Code is already available in your neural network section for d by dm and d by dc. But I will talk about this particular thing, and then I will talk about libraries. Libraries means like a TensorFlow, PyTorch, and Keras libraries. So how I will be able to build a basic neural network architecture or whatever architecture. So it's not like a neural network architecture is predefined. So you can build any kind of a network. When I will talk about a different network, you will get an idea that how I can design my own architecture and how I can design my own neural network as well, and how, what will the performance, in what direction I should design my neural network architecture to achieve what kind of things. So this is an idea you will be able to get, I think, down the line in the next 4 to 5 months. So find here, I was trying to show you like y is equal to mx plus c, and with respect to that, so I have explained you this entire things, like each and everything, like what is the actual meaning of learning. And we have seen that learning is nothing but it's a finding out a pattern, or learning is nothing but in other way, so it's finding out the relations, or it's finding out, I would say, a value of a parameter, so here parameter is nothing but m and c. So value of a parameter with respect to a error. So the whole objective was to decrease the error, so that my prediction and my, so y and y hat, my prediction and my expectation will be on a same level, basically. So this is called as a learning, and I will be able to do that by adjusting a value of m and c, for sure, if I'll talk about just this parameter, because m and c is someone who is responsible for giving you a correct or incorrect result. M and c is something who is responsible for fitting your line across the data set, any number of the line, any kind of a line which I can draw over here. Out of that, we have to select the best one. So MNC is something which try to give you the best fitted line. So best line will be something where error will be less, error will be as minimum as possible, and that's the reason. So we have introduced a concept called as a gradient descent. So with the help of gradient descent, so it try to reduce the error, it try to fall into a local minima where error will be equal to 0, and you will be able to find out some value of m, you will be able to find out some value of a c. So we will try to understand in today's class a similar kind of a things with respect to a neural network, because all the deep learning concept that we are going to discuss, and all the computer vision concept, and all the NLP concept, except libraries. I'm not talking about SPACY, GenSim, or NLTK libraries. I'm talking about BERT, Elmo, GPT-1, GPT-2, Transformer, Autoencoder, Encoder, Decoder, Attention-Based Model, RNN, LSTM, GRU. So these kind of a model are basically a neural network-based model. Now, so before getting into those kind of a discussions, you should understand a neural network in a first place. You should know that how my actual neural network looks alike, and then like how I will be able to interpret all of those neural network. You might have seen a different kind of a diagram. You might have seen a different kind of a diagram of a neural network, and you might be wondering that, okay, so neural network architecture will be kind of a circle kind of architecture that you might have seen over the internet. But let me tell you one thing, that no, it doesn't looks like that. So it's not like a circle kind of architecture that you will be able to find out. It's look different, and you will be able to see all the things what happens inside the neural network very easily, I would say. So even by unwrapping a different kind of a neural network architecture, you will be able to see, you will be able to get an actual intuition behind a neural network. That is possible, that is completely possible at any point of a time. And if you understand, I would say, actual architecture or actual module design in between different neurons, I would say, or different kind of models. So let me share. So let me share my screen again, and I will try to show you some of the models. So some of the model which we have trained, that we have designed. So there is something, there is a tool called as Neutron. So there is a tool called as Neutron. So with the help of, suppose if I have built a model, now if I wanted to know the architecture, or if I wanted to know that what goes inside and what comes out of those models, so Neutron is a kind of, I would say, a tool which always try to unwrap a model. Generally, we think that, okay, neural network is a like a black box kind of a thing, but I don't believe in that way. So I don't believe in that way. So like when we say like neural network is a kind of a black box, there is a different meaning actually. So it doesn't mean that I don't know what is the operations which is going inside. I know what is the operations which goes inside. When I say neural network is a kind of a black box, so I should always take a reference in terms of a probability, or in terms of a permutation combination of a weights that it is going to take. Now what is weight? This is the new word which I have taken. So basically I will try to explain you like what is a weight. So each and every neural network you will be able to unwrap, and you will be able to see exact architecture, what is going inside the input, or what is getting inside any other layers. Each and everything you will be able to unwrap, and you will be able to observe everything. Everything means everything, even on a value array level. So you will be able to understand, and you will be able to get a intuition. This is a one model architecture. Now if I try to show you some other model architecture, I can show you that as well. So this is another model. This is the another model that I have over here, and I know that what goes inside and what comes out of this model easily at any point of a time. So even on an array label, so I know that what kind of a data set it is trying to take internally, and then how the calculation happens. I can do all the calculation even manually. So even I know that, okay, this is the data which is going inside the model. I can try to do that. Again, I can save these arrays as well. I can save these weights as well for any kind of a model that I'm going to pick and choose. So for any kind of a model that I'm going to pick and choose, I will be able to know every values on a micro label. So I will get to know about it very easily. And this is what I will try to explain you that how to understand a neural network kind of a architecture, even if the architecture is too complex, but how you will be able to understand it layer by layer, and how you will be able to unwrap each and everything layer by layer. So what data is going inside, what data is coming out of which part of the model. So everything you will be able to get inside this one. So when we have, suppose if I'll go to Google, and then if I'll try to search maybe a neural network, or maybe a artificial neural network, if I'm going to search, so most of the time you will be able to find out this round kind of shape, this round kind of architecture. But this is not an actual way, I would say. So this is not how actually your network looks like. So if you wanted to know how your actual models looks like, so it's better to like unwrap all those things into a Neutron, and then have a look into that. You will be able to get a better intuition, and you will be able to get a different kind of a shape, different kind of a functions over here. Something goes inside, something comes out of that, and then you will be able to like understand that what is going inside, what is coming out of that, what kind of a calculation it is doing, why it is doing that calculation. Because this is something that you should understand, you must understand if you wanted to become an expert into a deep learning. And you should know that it's not a round kind of architecture that is going to help you out. As you can see in this particular architecture, this is the actual model unwrapping which I'm trying to do, the model which we have already trained model. But over the internet, so you will be able to find out this kind of a diagram over the internet. This kind of a diagrams are available, which is not intuitive, but yeah. So I will try to explain you even these things over here in this particular place. So this is the section which I'm going to start. It will take some time, maybe 2 days I would say, to close this session. So 2 days of time it will take to discuss all of those things. So let's try to understand it. Now, so we have seen that y is equal to mx plus c. So I was trying to learn a parameter called as m and c. Let's suppose, so I have a data set. So let's suppose I have a data set and I will be talking about a structured data set in the first place. Then I will be comparing these things with the image data set as well, and then sound, and then different kind of a textual data set, I would say. So let's suppose, let's see, we have a data set over here. Now, so inside my data set, so those who have done a machine learning thing, so I think you must be aware about a kind of a data frame. So suppose this is the data set x1, x2, x3, x4, x5. So this is the column, and then this is a like a label column. This is the label column, and this is called as a feature column that we have. So we have a x1, x2, x3, and we have a multiple data set in this particular place. So we have a row 0, 1, 2, 3, 4, 5, and so on. These many rows that we have. And let's suppose like in a x1, so I have a value called as 2, 4, 8, 2, 10, and then class is equal to 1. Someone has given us a class is equal to 1. Then again 5, 8, 10, 11, 2, someone has given as class 1. Then again 8, 9, 10, 2, 1, someone has given a class 1. Then again like 10, 20, 11, 13, 12, I'm just taking a random values, someone has given as a class 2. Then again 10, 18, 11, 19, and then 13, class 2. Someone has given class 2. So as you can see inside my data set, so I have a couple of rows. I have a couple of rows over here. So 0, 1, 2, 3, 4, 5, 6, and so on. And I have a couple of columns over here. I have a couple of columns in this particular place. Now, so what I have to do is, so I have to build a relations, or I have to build a model precisely. So I have to build a relations, or I have to build a model so that it will be able to understand a pattern between these data set which I have given and the label. Because ultimately, if I somehow my system is able to understand this pattern in between, so for sure it will be able to give me a classes, class 1, class 2, or whatever classes that we have. It will be able to give me a classes. So I have to like learn a pattern in between these data sets. So like a feature that we have given and the label that we have given. So just if I'm able to find out a correlation, if I'm able to find out the pattern in between, I will be happy with that. And for sure, I can say that I have learned relations. And in a future, if I'll try to give you a data 1, 2, 5, 8, 10, and if I'll ask you, okay, fine, tell me the class. If I'll give you this data, if I'll ask you, okay, fine, tell me the class, you will be able to tell me a class, whether it belongs to a class 1 or whether it belongs to a class 2 in terms of a label. You will be able to do a prediction. Again, same thing happens with the regression. So this is the classification example. Again, we have seen that in case of a supervised learning, there are two things which exist. One is a regression, another one is a classification. So this is the classification. Again, in case of a regression, what will happen? So in case of a regression, you have to regress, you have to build a relations in such a way that it is going to give you some real number in terms of some exact number. It is going to give it to you. This is what happens in case of a regression, I would say. So like if I'll ask you, okay, fine, so tell me the prediction of the incomes, that is basically a regression. If I'll try to ask you that, okay, fine, so give me the weather report, give me a temperature, again, that is a part of a regression that you will be able to find out. But if I'll ask you that, okay, so today it is going to be hot or today it is going to be a cold, so again, that will be a classification, I would say. You are supposed to classify your data set in terms of either hot or either a cold. So fine, this is this is the idea, this is the objective that we have to achieve. And again, I will be able to achieve this idea, I will be able to achieve this entire objective by using any machine learning model. So any machine learning classification model, I will be able to achieve it, like a logistic regression, or I can say like a SVM, or I can say a decision tree, or maybe a naive bias, or maybe like a XGBoost or ADA boost or gradient boost. Gradient boosting, or maybe a stacking approach, maybe by using a KNN, maybe by using, I would say, a random forest. There are many algorithms which is available inside a machine learning, by which I will be able to achieve this particular scenario. I will be able to achieve this particular situation. There is no if and but. There is no if and but with that. And again, when I talk about a machine learning model, so whether it's a KNN, whether it's a I would say a random forest or a decision tree or a SVM or a logistic regression. So everywhere it try to train some kind of a parameter. For example, if I will try to talk about a logistic regression, so logistic regression is nothing but log of p divided by 1 minus p is equal to mx plus c. So again here it is trying to design, or it is trying to draw the hyperplane, I would say, so which is based on the value of m and c. This is what it does. So everywhere it is trying to find out a relationship between the input and the output. So here it will try to determine the probabilistic value or probability factor of occurrences of one data set with respect to another. Again, if I will talk about a naive bias, so we try to find out a probability of occurrence of E with respect to a B, which is nothing but a probability of occurrence of B with respect to A when A is already given, into a probability of B divided by a probability of A, I would say. So again, this is another equation where with the help of a probabilistic value, so we try to, I would say, learn a relations that, okay, if this has happened, if this has already happened, then what will happen? So this kind of a situation, this kind of a scenario, we try to follow, or we try to fulfill in general in terms of a machine learning. Now, how neural network learns? How in deep learning? Because whenever a deep learning words comes into a picture, so the one thing which strikes in our mind is a neural network. So in case of a machine learning, based on the equation, based on the algorithm that we are going to choose, so every algorithm try to follow a different kind of equation. So it try to learn a equation parameter. So equation parameter, and then once I will be able to learn the equation parameter, I will try to give my input, I will try to get my prediction, or I can say y hat, or I can say output, I will be able to get. But what happens inside a neural network? So how neural network will be able to learn? For sure. So like I was talking about, I have given you the example that in every part of our body, so there are neurons. Some of you even I have seen a question and answer that some of you have sent me a question that whether we have a neurons in our hand or leg or not. So just try to go to Google, search for it. So yes, there is a neurons in your entire body. It's not like there is a only neurons which is available in your head. Go and search on Google. You will be able to find out these things. I'm not going to talk about biology, but yes, there is a neurons which is available in every bits and pieces of our body. Every neurons is responsible for getting some kind of a data. Now, so it tried to send all those things in our brain. It tried to correlate each and everything, and then based on our previous experience, so it tried to do something. Like I'm able to speak something as of now. How I'm able to speak, how I'm able to talk about this particular table, or maybe a data set, or maybe this log of p by 1 minus p is equal to x plus c, or p of a of b. Because some point of a time, I have seen this kind of equation. I have heard about something. I have found out a relationship in between. And then, so when I'm trying to explain you, so basically it's an output. It's an output which I'm trying to give you. Sometimes, so it's a y hat which I'm trying to deliver. It's a y hat which I'm trying to deliver. Sometimes I may make a mistake, possible. So sometimes I may make a mistake while explaining the algorithm, possible. And in that case, you can tell me that, no, this guy has not learned it properly. Whatever he's trying to explain me, generally I will not make a mistake. Don't worry about that. Don't get scared, because I'm good with the topic which I'm going to teach. So you can check my other videos as well, which is the complex one in terms of architecture. So I'm good with the teaching. I would say I'll not make a mistake, but still there is a chances. There is a very high chances that I may skip something. There is a very high chances that I may deviate from the topic. There is a very high chances that whatever I have to deliver as a y hat, you all have joined a class. Now I have to teach, I have to deliver something. I have to produce a y hat based on my learning. Now it could possible that sometime I will try to give you a correct y hat, means whatever I'm trying to say is completely correct. It could possible that I will try to give you a false information. I will try to teach you into a wrong way, I would say. So that is basically a error. That is basically a error, I would say. There is a difference between original, the actuals, and the predicted one, or the things which I'm trying to speak. So how am I able to speak? Because based on my past learning, I have already experienced those things. I have already found some kind of a correlations, and that correlation I'm trying to teach you. This is what happens even in case of a real time. If I'm able to walk, as a kid, you will not be able to walk. As a newborn, people, as a newborn child will not be able to walk. So we all learn that how to walk, how to detect the objects, how I can say apple as an apple, bottle as a bottle, laptop as a laptop. So everyone we try to learn from somewhere. Everything we try to learn from somewhere. If I'll show you one laptop, it's not like again and again I'll have to tell you that this is the Dell laptop, this is the HP laptop, this is this laptop, this is the Mac laptop. Everything, whatever same kind of a configuration, same kind of a object you will be able to find out, you will say that as a laptop. Simple. If I'll tell you that, okay, fine, this is the mobile, this is how mobile looks like. Now there are variety of mobile. You will say that, okay, fine, everything is a mobile. So you have learned something somewhere, and based on that perspective, so you are trying to deliver in a later stage. You are able to recognize in a later stage. Same thing is been done by a network as well. Same thing is been done by the equation as well. So now, like we as a human brain used to learn, used to find out a relations based on the different kind of a data set that we used to receive from our receptor neurons. So in the similar way, artificial neural network also try to learn. It try to find out the relation. Now let's try to understand how it will try to find out the relations and how it try to learn something. So again, I'm going to start with the same circle kind of a diagram that you will be able to find out over the internet, but don't think that this is the actual neural network architecture. As I have shown you already a picture in my Netron. So Netron is one of the tool which has been used to unwrap this entire neural network. So any kind of a neural network, any kind of a model, whether it's a H5 model, whether it's a PV model. Now, what is H5? What is PV? You will get to know in a future classes. So basically, like this is not how my actual neural network looks like, but as a learner, as a beginner, so we'll try to start from here. So even into an artificial neural network, so there will be a input layer. There will be an input layer which you will be able to find out. So suppose we have a input layer over here. So layer by layer we'll try to move. So we have an input layer. So we have a x1, x2, x3, x4, x5. So we have a 5 input layer over here. So it's completely fine. We have a 5 input over here. Just try to visualize it. So just try to rotate this table, transpose this table, and then try to understand these things. I think you will be able to understand in a better way. So here, let's suppose we have an input layer. Input layer is nothing but it will take a data. Now here, what is the data that we have? 2, 4, 8, 2, 10. So I'm trying to give 2, 4, 8, 2, 10. So this is the data set which I have given. This is the data set which I have given over here according to the data set which I have taken inside my table. Same data set I'm going to use. Now this is the input layer. So there will be a receptor neuron, or there is a receiver perceptron. So neurons is basically a biological word. It's been used for the human being. If I'm talking about artificial neurons, that is called as a perceptron. Again, don't try to engage yourself in terms of names. Names wise, you can say that as a neural network, neurons. No one is going to stop you. No one is going to cross you that you are saying a wrong or right thing. It's completely fine. So I'm just trying to tell you, like, okay, so this is the perceptron that we have over here. And I'm trying to send a data. I'm trying to send a data from the table. So I'm trying to insert a 0th record. Now, what I have to learn? What is my objective to learn over here? So my idea and my objective is to learn a class 1 or a class 2. So it belongs to a class 1 or it belongs to a class 2. So output wise, y wise, it can give me 1 or it can give me 2. There is only 2 labels which is available inside my data set as of now. Going forward, it can be a 1,000 class classification we can do. Yes, we are going to do that. Or maybe 10 class, 100 class, 1 million classes classification we are going to do. So here we are going to insert a data. There will be an input layer where data will go into a picture, and I'm expecting what? I'm expecting either a prediction of a class 1 or I'm expecting either a prediction of a class 2. It's completely fine. So it will try to go inside this one, and then in a next layer, what will happen? So in a next layer is called as a hidden layer. So in some of the neurons, some of the neural network, you can keep a hidden layer, or whatever is going as an input, you can try to give as a output. That is also possible. So here I'm going to design basically hidden layer. Now what hidden layer does? basically. What is our roles and responsibility of a hidden layer? So I would say in a layman term that hidden layer is a layer responsible for learning. Now, why I'm saying that it is responsible for learning and what kind of a learning it try to do. So here you will be able to find out that I'm trying to give these kind of inputs. All of these inputs I'm trying to give. Now, it could possible that there is a relationship in between these inputs which I'm trying to give and the output. If I'll try to write these things in terms of a linear equation, it will be m1, x1, m2, x2, m3, x3, m4, x4, m5, x5. So we have a multiple m over here. If I'll try to fit these things on a logistic regression, so we have a multiple one, and then probability we have to find out for the class 1, or probability we have to find out for the class 2. So I have an input. I'm trying to send a data to my neural network. So there will be a receiver network. There will be a receiver layer. So which will just receive a data. It will not do anything. Now actual learning will happen into a hidden layer. So let's try to understand how it is going to do that. So whenever I'm going to send a data, so it could possible that it is going to send a data from a two input as a combination of two input, or it could possible that it can try to send a data from the multiple inputs. I would say multiple inputs it can try to send a data set, I would say. So here I'm trying to send a data somewhere from the multiple inputs. We are trying to send a data somewhere from the single inputs. So multiple kind of permutations and combinations are possible. Multiple, I can try to give only 2 to the next one, or 248 or 4828. Many kind of permutations are possible. So I am trying to give all the kind of a permutation into my hidden layer. Now what it will do with that, what will happen in that particular case, and what kind of a data which will go inside my hidden layer. So in a hidden layer, so I have drawn only a 3 neurons. It could possible that I can have 100 neurons, I can have only 1, or I can have only 2. There is no problem with that. Now, so here and again, so I have drawn this this connections. What is the meaning of this connection? So we will try to understand that as well. So here, whenever you try to send a data, whenever you try to send an input, so suppose if I have given 2 as an input, and this is a data which is going from here to here. So if you will try to observe in this particular place, so this is a 2, this is a 2 which is going from here to here. So what kind of input it will receive from this 2? So this input that it is going to receive over here is nothing but, let's suppose I'm trying to denote something as W1 over here, W1. So the input which will go inside this neurons is nothing but a 2 into W1. This is the input. Now again on top of that, so we try to add a biases, a layer wise biases we try to add. So let's suppose bias is equal to B. Bias is nothing but an error that I'm trying to introduce. So the total input which will go from this particular 2 to this particular layer, will be this one, just from this one, the things which I have marked into a green. So input into weight, this is called as a weight. So you can try to you can try to compare these things with the m that we have discussed in y is equal to mx plus c. That's the reason. So I was talking about y is equal to mx plus c in a first place, I would say. So here I'm trying to give a input in this particular place, input into weights. I'm trying to multiply plus biases I'm trying to add, and it's exactly equivalent to the equation that we have discussed, which was nothing but y is equal to mx plus c. So it's completely fine. I will be able to get that, but you will be able to find out that sometime I'm trying to set a 2 input, 3 input, 4 input, 1 input. So I'm trying to send a different kind of a combinations over there. What is the meaning of that? Then what will be the exact input which will get inside my data set? So here again, from here, let's suppose I'm trying to send another input. So this connection I'm trying to derive as a W2. I'm trying to derive as a W2. So what is the input which will go from this one? From this one. So the total input which will, or the input which will go from here will be, I can say, so W2. So 4 into W2 plus biases. This is the input which it will try to go inside this one. So the total input which will go inside this neurons will be equal to a summation of, I can say, so Xi Wi plus Bi. So summation of this is going to get inside this one. Now it will be 2 of W1 plus B plus I can say 4 of W2 plus B. So this is the total input which is going to get inside this particular neurons, the hidden layer neurons or a receiver hidden layer neurons which we have. So if you will try to combine this thing, so it will be equal to 2W1 plus 4 W2 plus 2B. So this is the total input which will go inside this one. So this is how calculation happens, I would say. Now you will ask me a question that why you have given W1, W2 and what is the significance of using a W1 and W2. So as we have already studied that here M and C is nothing but it is trying to derive a relationship in between Y and X. So in between my input and output. So if there is someone who can derive a relationship, so it's basically M and C who is deriving a relationship. So what kind of a relations? Because we are trying to learn the relations, as simple as that. We're trying to learn the relations. So M and C was the factor which was trying to derive the relations. Now here I have introduced a value of W1, W2, W3. So whatever connections that we have, so I'm trying to refer that as a W1, W2, W3, W4, W5, W6 and Wn, I would say. So this is basically a core relationship which I'm trying to derive. So I can just name it in this way. So W1, W2, W3, and this is W3, this is let's suppose W4, this is let's suppose W5, this is let's suppose a W6, this is let's suppose a W7, this is W8, this is W9, so far so forth. This is something that we have drawn over here. Now as we know that this is a total data, this is the total data which will go inside this particular neurons, and like I told you, it try to take all the combination, because if I'm talking about a linear equation, if I'm talking about y is equal to mx plus c, so it just try to understand a relationship between y and x, I would say. And just try to understand that relations. But let's suppose I'm talking about a pictures. I don't know basically. Suppose if I'm talking about a pictures, pictures are nothing but a pixels. So there is a orange, there is a green color, there is a orange color, there is a different kind of a shape. If I'm trying to learn this picture, a pattern inside this picture, suppose there is a picture of me. Suppose if you're trying to learn my face, so after one pixel, there will be another pixel, there will be another pixel, there will be another pixel. So unless and until you are not able to learn the relationship in between the pixels, for sure you will not be able to identify me as me, I would say. So that's a reason we are trying to take all the permutation combination. It will try to learn the relationship. It will try to remember. It will try to keep the significant one. And then, so it will try to change the value of the non-significant one after a learning, after a training. That's the reason. So I'm saying that any permutation combination can go inside this one. Any permutation combination. Doesn't matter that what kind of a permutation combination you are trying to give, I would say, inside this one. Now, so yes, it's completely fine. So here I'm trying to give a weights and then I'm trying to give a biases. Now it could possible that all the weights could be almost same or different. It could possible that all the biases initial point, because see, as of now my problem is, so when I will start training this data, when I will start inserting this data, my problem is that I don't know relationship. That's my problem actually. That's the reason we are using neural network. So that it will learn on behalf of us, right? So my issue is like, I don't know a relationship at all. I don't even know what will be the value of biases. I don't know anything actually. I don't know any kind of a relationship. And that's the reason so I'm using a neural network. So in general, we try to take a random weights, and in general, we can try to take a random biases. You can try to take a same bias, or you can try to take a different biases as well. Ultimately, system will try to learn. Doesn't matter, even if you are starting from the same biases, maybe bias is equal to 1 or bias is equal to 0, you might have observed that many people used to take. So you can try to follow that idea, that approach, or else in my neural network, I will show you when I will try to design a raw neural network. So from a very raw TensorFlow code, or even without using a TensorFlow code, I can design neural network. I'll show you that. Just by using a Python core, I can design a neural network basically. So I have already mentioned those things in your syllabus as well. So without using any TensorFlow library, any kind of a Keras library, any kind of Python library, just by using a simple Python understanding. So here what will happen is, So I can try to take a same biases, I can try to take a same weights, because initially whatever I'm going to take doesn't matter at all, because I don't know the relationship. So even if I'm going to take a same biases, it's fine. Even I'm going to take a different kind of a biases by generating a random data set, that is completely fine. I don't have to worry about that. So because ultimately it is going to tune it. Ultimately it is going to find out the new value of weights and new value of biases. Fine. Now, so I was trying to give a input. Now, so like I told you, so in every neurons, it could possible that there will be a combination, different kind of a permutation combinations of the input, which it will try to accept. Now, what input it will expect? So simple, input into weights plus biases. That is the thing. If here we are receiving 3, so in this means that 2 into this weights, so 2 into W3 plus 8 into W5 plus I can say 2 into W7 plus 3 biases. Again, biases is same, I would say. So this is what our input data you will be able to give inside this neurons, and this is the input data that you will be able to give inside this neuron. So for the first neuron, I have written you the calculation. Now, so what happens inside a hidden layer and why hidden layer is been used? So inside a hidden layer, we try to use, or we try whatever input that we have taken over here. So we try to pass all of those inputs into something. So inside a hidden layer, there is something called as activation function, ACTIVATION, activation function you will be able to find out. So basically it try to send all of those data inside a activation function. Now, what is this activation function? Why I'm using this activation function in a very first place, I would say. So so why I'm using a activation function, and what is a use of using this activation function? So let's try to understand that, because again, many people generally gets confused, and the line that you will be able to find out over the internet is most of the time it's not clear. Basically, it never explains you the actual roles and responsibility of a activation functions. So let's try to understand that activation functions. So there are many activation functions. There are more than 50-60 activation functions which is available. Now I would like to start from the very basic one, and there will be a separate class I'm going to take where I will be talking about all the activation function in terms of a mathematics, which one is good, which one is bad, which one you should choose in what kind of a situation. Every comparison I will try to do one by one. But as of now, I'm just trying to explain you the meaning of activation function. What is the significance of using activation function inside the hidden layer, and why we are passing all the data set inside the activation function. So the first activation function that you are going to encounter as a beginner is, there is something called as a sigmoid activation function. Now, how sigmoid looks like? So if I'm talking about a sigmoid, so basically a sigmoid activation function looks like this one. So 1 by 1 plus e to the power minus of x, I would say. So this is how it looks like. Now, if you will try to draw the sigmoid functions, let's suppose this is origin, this is x, and this is y, that is for us. So this is how the sigmoid function looks like. So in between 0 to 1. So doesn't matter what kind of a x value you are going to put, starting from a positive minus infinity to plus infinity, it is always going to give you a data in between 0 to 1 itself. So this is called as a sigmoid function. So doesn't matter, you can try to put any value of x over here. You can try to put 1, 200, 1,000, million, billion, doesn't matter at all. You can try to put any value of x in this particular place, and then it is going to give you all the data in between 0 to 1 itself. This is what a sigmoid activation function. Sigmoid function. Let's forget about activation function. Let's forget about the name called as activation. Let's assume that there is no name exist as an activation function. So there is a function called as sigmoid. So in sigmoid, what happens is, so whatever value of x that you are going to pass, it is always going to give you an output in between 0 to 1, always. Likewise, there is a hypertangent function which always try to give you a value in between -1 to plus, or 0 to 1, I would say. There is another function called as a ReLU function. So it always try to give you a value maximum for x is equal to x is, I would say, greater than 0, for x lesser than 0, so it will try to give you always 0. There is something called as a leaky value. There is something called as a max out activation function. So there are many activation functions, so almost 10 plus activation function I will be talking about in terms of mathematics itself and in terms of implementation in a class itself, so that going forward you can utilize all the activation functions, because it always plays a crucial role while doing a training of the neural network. So fine, as we know that there is an activation function, and we are trying to pass a data set inside the activation function, and we know that if I'm using this function, this sigmoid function, simple sigmoid function, if I'm going to pass any data, so suppose f of x is equal to 1 by 1 plus a to the power minus of 0, if we are going to pass, so a to the power 0 is equal to 1, so 1 by like 1 by 1 plus 2 is equal to 0.5. So it is always going to give you a value in between. If you are going to pass maybe 1 by 1 plus e to the power minus of maybe 1,000 million billion or whatever, it is going to give you always a value in between 0 to 1 itself. Except 0 to 1, it is not going to give you anything else. And this is where activation functions comes into a picture. Now, what is a purpose of using activation functions? So many books or many articles, wherever you will try to go and you will try to search, they used to say that activation is been used, or activation functions is been used to achieve a non-linearization into a data set. Now, when I say that activation function is been used to achieve a non-linearization of the data set, so what is a meaning of that? What is the meaning of non-linearization and what activation function actually does internally? So let's try to understand that particular part and why we are trying to make this kind of a statement that it try to achieve a non-linearization inside a data set, and what kind of a output my activation function is going to give it to me. So you might have heard about a topic, or you might have heard about a concept called as normalization or standardization into a machine learning. So in machine learning, so even in statistics, so we frequently use this term called as normalization or standardization. Now, what is the meaning of normalization, or what is the meaning of a standardization? So normalization, I would say, simply means that, so we are trying to bring a huge volume of the data set in between certain scales. So let's suppose if I have given you a data set called as 10 or 20 or 30 or 40 or 100 or 1000 maybe, or maybe if I have given you a 200 in this particular place. So normalize, if I'll try to normalize this data set, it means as of now I have a data dispersed in between 10 to 1000. So minimum is 10, maximum is 1000. So now my scale is too huge. My data is dispersed in between 10 to 1000. So basically, whenever it will try to learn a relationship, somewhere it will jump from here to here, here to here, here to here, here to here, and then it will try to learn the relationship. And again, in this way, so it could possible that my model will not be able to learn a relationship in a better way, because I have given a huge variety of the data, or the scale which I have chosen is having a huge wide range. Now, what if I will try to limit this out? What if I will try to like scale it down? I will not try to change the actual meaning of the data. Basically, I will try to scale it down. So if I will try to scale it down, so in that case, yes, if I have to learn something in between a smaller range, if I have to learn something in between a smaller range, so I will be able to learn into a much better way. For example, just I'm trying to give you example. Don't try to correlate with these things. So suppose we have a 10 and we have a 1000. So in between 10 and 1000, so we have a distance of 990. I would say. Now, if I'll try to talk about a log of 10 and log of 1000, anyone who can tell me what is a log of 10 and what is a log of 1000? Anyone? Yes. Okay. So many people are trying to give me a reply, I would say. So log of 10 people are saying is equal to some people are saying it's equal to 0. Some people are saying it's equal to 1. So log of 10 is equal to 1. Log of 10 is equal to log of 1000 is equal to 3. Now, so if I will try to perform this kind of operation, so log of 10 is equal to 1, log of 1000 is equal to 3. Now, there was a difference in between this 10 and 1000 was 990. Now, if I talk about this differences, what is the difference? 2. What I have done is, so whatever I have done with this 10, same thing I have done with 1000. It means that what is the mean? What is the meaning of that? So in a childhood, you must have seen and you must have solved the equation where we try to add, multiply and divide by the same volume of the data in a numerator and denominator. So this is the kind of equation that we used to solve in our childhood, and we try to consider that there is no effect. There is no effect in my actual data set. So if I'm trying to perform a same operation with all of my data set, so I'm trying to say simply that I'm not trying to change the meaning of the data. What I'm trying to do over here is I'm trying to change just a scale. And here it's the same data set which I have transformed. And if I'll try to check a minimum and the maximum distances in between, it's just 2. So out of 990 of the variance, I would say, I think I'm assuming that you understand the meaning of variance and standard deviation. So here it is able to, understand a variances. So instead of understanding the variance in between this person, I will try to understand the variance in between just these two. And that's a reason. That's the reason. So we are trying to do a normalization, I would say, or whenever I say standardization in that, so I try to bring down a data set in between 0 to 1, I would say. So normalization or standardization that we use to do, so that I will be able to reduce the scale of all of those input data set, so that it will be easier for me to find out a relationship. So when I say, why I was talking about this normalization terms over there. So normalization simply means that normalize a data set onto a different scale. Just try to change the scale. So I'm not changing the meaning of the data actually. I'm just trying to change the scale. Now, as we have observed over here, so if we are using a sigmoid function, doesn't matter what value of x that we are going to give in between minus infinity to plus infinity, it is always going to give me. It is always going to give me, I would say, output in between 0 to 1. This is the only output which is trying to give it to me, always in between 0 to 1. And there are other different kind of activation functions also which does exist. And I would say that different activation functions try to, I would say, give you an output into a different way. Now, so activation function actually means that we are trying to normalize a data set. We have a huge dispersion. We are trying to bring down our data in between certain range. That is a meaning, I would say, that is a meaning of, I would say, activation functions. And the other meaning, this is one of the meaning. So activation simply means that we are trying to activate. Some people used to say that, okay, so we are trying to activate it, we are trying to deactivate it. What is the meaning of it? What do you mean by activation or deactivation? So why we are using activation function for doing that? Actually, so we always try to normalize a data set. And we try to normalize a data set by taking a activation function, by passing a data inside the activation function. That's one thing. So we try to normalize a data set, to bring down my data set in between certain scale. So we are trying to use activation function. Doesn't matter what kind of activation functions we are going to use. Every activation function normalize a data set into a different way. For example, so here I have taken a log. It could possible that I will take a root of 10 and I will take a root of 1000. It is possible that I will try to take a root of 10 and root of 1000. So here also I'm trying to apply a root. Here also I'm trying to apply a root, square root, cube root, power 4, anything I can apply. Root of 10 is equal to 3 point something, and this is nothing but 33 point something, right? And even in this way, there was a distance of 990 in between my actual data set, between 10 and 1000. Here I'm trying to bring down my scale. So here I have done a different kind of a normalization. Here I have done a different kind of a normalization. Likewise, there are another 1000 kind of a normalization which is possible. There are another 1000 kind of a normalization. In both the cases, I am trying to do a normalization itself. I'm not changing the meaning of the data. What I'm trying to do is I'm trying to change the scale of the data. Simple. Just remember this concept and don't get confused at all. So here I'm trying to perform a normalization operation, I would say. Same thing is been achieved by your activation function. So make sure and be very clear on this topic. When I say I'm trying to pass my data set inside the activation function, I'm trying to perform a normalization, nothing else I'm trying to do over here. So as we know about a sigmoid function, so sigmoid function always try to normalize a data set in between where to where. Whatever data set you are going to pass, the output will be equal to 0 to 1 itself. So it's completely fine. Now let's come to this topic again. So let's suppose if I'm trying to implement a sigmoid activation functions over here. Let's suppose I'm trying to send a sigmoid activation function. I'm trying to give in this particular place, which is nothing but, I would say, 1 by 1 plus e to the power minus of x. This is what I'm trying to send in this particular place. That's completely fine, not a problem. So what I'm trying to send as a x over here in a first neuron. So I'm trying to send x as this value because this is the true input which is going inside this one. So if I will try to write a activation function for this one, so 1 by 1 plus e to the power minus of x is equal to f of x, I would say. So we are trying to send actually e to the power minus of 2 of w1 plus 4 of w2 plus 2 biases. So this is considered as a x. This is the input. So here x represent this entire input that we are going to send in this particular sigmoid function, I would say. And it will try to convert this entire things in between 0 to 1. So the output which you are going to get will be some values in between 0 to 1 for sure. It means whatever values that we have taken, whatever input that we have taken, so it is trying to decompose those values. It is trying to decompose or normalize these values in between 0 to 1. Now, don't think that it is trying to give you a probability. Many people used to think that it is trying to give me a probability. No. Sigmoid function has been used to find out the probability as well. That is true. I will agree with that point. But here, I'm not doing that thing. I will not agree with that point. If you will say that inside the activation function, I am trying to find out the probability. If I would have used a sigmoid function in outer layer, then I can say that I'm trying to utilize this function to find out the probability, because sigmoid is a base of a logistic regression. Logistic regression try to find out the probability of occurrence of one instance with respect to other instances. But same thing is not acceptable in case of an activation function. So just remember, here we are not trying to find out a probability. Here we are trying to do the data normalization. If we are using a sigmoid function as an activation function, you should be very much clear about this line, because people makes a mistake always, and they always gets confused that whether I'm talking about a probability over here. No, I will try to use a ReLU, and in ReLU, so you try to get for all the positive data sets, so you used to get basically a rectified linear unit. It will come into picture, those who have not heard about the name, just for your information, FYI. So there you will be able to get a maximum of the data set for all the positive values. For all the negative values, it will be flat 0. Again, there is something called as a I would say hypertangent. There is something called as a leaky ReLU. There is something called as a maxor and all those things. So we'll try to understand that. So here, this is the input which I'm going to pass inside my activation functions. So in between the activation function, this is the input which I'm going to pass in this particular one. Now, so after passing an input, after giving a value of x, it is going to give me some kind of an output for sure. And let's suppose like I have some another one neuron I'm trying to keep over here. So one neurons I'm trying to keep over here. So you will be able to get some output from here. So suppose O1 you are going to get, again from here you are going to get O2, and suppose here O3. So you are going to get an output from every neurons. Now how you are going to get an output? So suppose if I have used this function, sigmoid function as of now, because we are trying to learn these things for the very first time, that's the reason I'm using sigmoid function. So suppose this sigmoid function has given you O1 output. All the output will be different because the input which we are trying to send combination. So here, let's suppose I'm trying to send this combination, and this combination. Now, so in the other one, I'm trying to send this combination, and this combination. So again, I'm trying to send a different kind of a combination into different places, I would say. So depends upon the combination that you are going to send. So yes, like here we are trying to send a 2 weights, here 3 weights, here like a 4 which is going inside that. Again, I'm not the one who is deciding that how many data, how many weights will go inside. It takes all possible permutation combination. Make sure and keep these things in mind. All possible permutation combination. Now, why it takes all the possible permutation combination? What is a logic behind that? So basically, the logic behind taking all the permutation combination is, so if I'm talking about y is equal to mx plus c. So here we are just trying to consider only one linear relations. Here, relationship between y and x, I would say, just one linear relation, I would say. But if I'm talking about the images, if I'll show you some of the pictures or whatever you are able to find out in your screen as of now, so I don't think that there is a linear relationship or there is certain kind of this, there is a pattern. So neural network, if I'll try to scan this image or if I'll try to feed it inside my like a object detection, it will be able to tell me that, okay, it's a neural network which I have designed. But that relations are not normal. Relations means what? A relationship between the pixels. Or it could possible that this and this relation, this and this relation, this and this relation, this and this relation is not linear with this one, I would say. So that's a reason. So we try to take all the permutation combination in a linear equation. It try to take only one. It try to understand only one relation, but it could possible. And for sure, if I'm talking about some kind of images, I don't even know what kind of pixels are arranged in what way. Suppose if you have taken my picture now, like in this lighting condition, I will switch off one of my light over here. You will take again a picture from the same side. Side is not going to change. Camera is not going to change. Your mobile is not going to change. But still you will be able to find out that my pixels are different. If you try to take my same picture in maybe into a daylight, maybe from some other distances. Suppose now if you have taken a picture from a 2 feet distance, then if you change the 5 feet, if you change the 100 feet, I would say it's change. If you try to change the camera, again, it's going to change. Now, so these things are going to change. Person wise, I'm the same person. Object wise, I'm the same object. But my pixel arrangements are changing into a different images. Now, how system will be able to understand those things? Because in every images, just you will take an image within a second itself, just by clicking by like your camera, just by twice. In both the places, you will not be able to get a same image. Even if you're trying to click in a fraction of a second, you will get some pixel differences in between. If you wanted to observe the pixel differences, just try to click the images and try to load into a paint and then hover your mouse, you will be able to get a pixel value in a bottom. So there will be some pixel differences that you will be able to find out for sure. Or there is some differences between the data set that you will be able to find out. If you are trying to say something, if you're trying to speak something, right? Or second time, if I try to explain you the same neural network, right? I will be using a different line. I will be using a different word, different phrases. I will be using last time when I have taken the class, you can go and you can watch the videos, which is already available. So I was trying to explain a neural network by using some other word, by taking some other context. This time I'm trying to take some other context. Next time I will be using some other context, but my topic is not going to change. My actual objective is to teach you neural network. This is what I'm trying to achieve. Sometime by using some different combination of the words, phrases, lines, pictures, diagram, whatever I'm trying to draw. So my objective is same, my goal is same, but to achieve that goal, I'm trying to use a different combinations. Now, system is supposed to understand all the combination, and all the combinations are not normal, or it's not linear. It's not like a y is equal to mx plus c, and that's the reason. All the relations are not linear, and that's a reason. So we try to take a permutation combination of a different inputs. So system try to learn a relations that, okay, so whether this relation is valid or the other one is valid. System try to learn it. How? We will try to understand. So system try to learn all of those relationship, I would say, over here. That's the reason. So we try to take a permutation combination. So I think you guys are very much clear in terms of a relation that we are trying to keep in this particular place, permutation combination of relation. So this has been used. This has been used, I would say, to achieve a non-linearity. This is the reason we are trying to take the permutation combination. Now, sigmoid, or I can say like activation function. So inside the hidden layer, activation function is been used. Activation function is been used in terms of a normalize a data set. Because my data dispersion is used, I don't have to like take all the data dispersion. I will try to downscale these things. I will try to normalize it. I will try to normalize it so that my data dispersion will be less, and it will help me out to find relations. If I have a huge data dispersion as a human being, I will not be able to interpret the relationship between the data. But if I have a small range, maybe I will be able to interpret my data set, a relationship that I will be able to understand into a much, much better way. Right? That's the whole idea, and that's the reason we are using a sigmoid. So I think I'm assuming that you are very clear with why we are using a permutation combination. One thing, input wise you are clear. Now permutation combination wise you are clear, and why we are using our activation functions. You are very clear on that. Now let's talk about our weight and biases, because I have not discussed about weight and biases. What is the significance of weight and biases? So weight and biases is something which is trying to define a relationship between the inputs that you are trying to give to the next one. So suppose like so here I'm trying to multiply 2 with W1 plus biases I'm trying to add, and you will be able to find out that as an individual input, it is trying to take as a linear, but we are trying to add a multiple one over here, and which is responsible for achieving a non-linearization. I would say all the permutation combination we are trying to take in this particular place to achieve the non-linearity into a data set. So it will try to non-linearize the data set more and more, and again with the help of sigmoid function it will try to increase those non-linearity. So we have taken some data, but we have changed this data set into some other scale. So again there was a non-linear combination which I have taken. So here I'm trying to take this as an input by taking all the permutation combination, and then again we are trying to achieve a non-linearization on top of that one. And we are trying to normalize a data set as well, even in this particular place. It is so if I'll talk about a weight, so weight is something which is trying to define the relationship between the input and the input which is going to get inside the next layer, I would say. So like I have shown you different kind of a dendroid and exomes. If I will try to draw this diagram, so you will be able to find out that we had a exomes and we have a dendroid. So there was a receiver that we had, I would say, and there was a transmitter that we have. So it could possible that there is a relationship between the different data. So let's suppose I'm trying to speak something. So just by looking into my screen, I'm trying to draw something, and then with respect to that, I'm trying to speak. So it means that I'm trying to receive something, and then I'm trying to say something based on the image and the diagram. So there is some relationships, I would say. And this is the relationship which I have already learned by doing a study or by listening up to some of the lectures, I would say. So here, this weight is trying to define a relationship between the input and the data which is going to get inside this one, I would say. Now, so what is a relation? As of now, I literally don't know about the relations. What is a relationship which will come into picture? So I don't have any idea about a W1, W2 and the biases as of now. What I will do is, so maybe I can try to start with the random weights. So we always try to start with the random weights, and in transfer learning, the same concept is going to change. We always try to start with the known weight into a transfer learning. So there are a different kind of a learning that you will be able to observe. So here I'm trying to start with, I would say, random weights, because as of now, I don't have any clue. I don't have any idea. I don't have any relation. If you remember, y is equal to mx plus c definition or the derivation that we have done last time. So there I was first of all trying to find out m and c by using two coordinates of the data, or else the second another approach will be start from the random value of m and random value of a c. That is also possible, and then you will be able to fine tune it. In the random value, it can take some more amount of time, because it will have to adjust lots of times the errors, and you will have to send a data set for multiple iterations, I would say, or multiple epoch, or you can try to start with the known data set. So along with that, so it will start adjusting your value of m and c. So it's completely fine. I'm trying to give a weights, and initially I don't have any clue or any idea about the weights. So I will try to start with the random weights over here in this particular place. And this is what I have to learn. If I have to, because weight is something which is trying to derive the relationships. Weight and bias is something which is trying to define that what is the relationship between the input and the next one which is going to get. Now again, so this will give me some output, suppose O1, O2, O3, some numerical values, because if I'm going to take some random numerical weights over here, So let's suppose I'm going to take W1 is equal to 0.2, W2 is equal to 0.4, and biases is equal to 1 as of now. Now, what is a data input which I'm going to give? So I'm going to give 2 into 0.2 plus 2 into 0.2. So W1 is equal to 0.2. So this is W1, this is W2, and I would say 4 into 0.4 plus 1. So if you will try to sum it up, so I would say 0.4 plus like 1.6 plus 1. So this will be equal to, so 2, so this will be equal to 3 that you will be able to get. So total data that you are going to insert inside 1 by e to the power minus of x is equal to 1 by 1 plus e to the power minus of 3. So this is the data that you are going to insert inside this one as a combination of these two. And then, so whatever data it is going to give you, 1 by 1 plus e to the power minus of 3. So that will be the output one if I'm talking about a mathematical equation. So fine, it is going to give you some numerical value, just like you have inserted some numerical value. Now again over here, there will be a weight. So W10, W11, W12. Now, so these are the weights which is going inside the final layer, I would say. These are the weights which is going inside the final layer, I would say. So here, I'm talking about, I would say, a two-class classification. I'm talking about a binary class classification in this particular place, as you can see. So there is a binary class classification, there is a multi-class classification, and things changes in multi-class as well as into a binary class. So first of all, I will try to talk about binary classes where I have just two classes. Binary means two. So two-class classification. So I will try to take again a random weights. Let's suppose like O1 I have received as maybe let's suppose O1 is equal to 0.5 because I'm trying to pass all those things into a sigmoid. So any output that you are going to get, you will get in between 0 to 1. So O1 is equal to 0.5, O2 is equal to 0.6, and O3 is equal to maybe 0.1. This is the data that you have received. So 0.5, 0.6, and 0.1, and W10 if I'm trying to take. So W10 is nothing but, I would say, let's try to take a random weights because I don't know the relationship as of now. So W10 is equal to maybe like I can try to do W10 as a 0.5. I'm just taking a random weights, and W11 is equal to 0.2, and W12 I would say is equal to 0.3. So these are the weights which I have taken. So these are the output O1, O2, O3 which I am able to get. This is the weights which I am able to get out of this one. Now, so it will get inside this. So summation of, so again, same formula that we have discussed over here that will be applied in this particular place. So here total data which will get inside this one is 0.5 into 0.5 plus means output 1 into W10 plus output 2 into W11. So 0.6 into 0.2 plus, so output 3 into W12, so 0.1 into 0.3. So this is the total amount of a data which will go inside this calculation. So 0.5 into 0.5, so what will happen? So it will be equal to 0.25 plus 0.6 into 0.2 is equal to 0.12 plus 0.1, I would say 0.1 into 0.3. So this will be nothing but 0.03. If you will try to sum it up, so 0.4 that you will be able to get in this particular place. So 0.4 is a total data which I am trying to send, and this I am trying to claim as a output layer. This is the output layer which I'm trying to claim. So 0.4 will get inside this one. Now I'm trying to, I have to find out the probability of occurrence of one classes, because we know that in case of a binary class classification, so if I will be able to know the probability of occurrence of one classes, so for sure I will be able to give the probability of occurrence of the another classes. So as we have sent only first data set, so I will be assuming that it is going to give you probability of the first data set. So I will try to use again a same sigmoid function, because sigmoid function is being used as a probability function as well. And in a binary class classification, I can use it. I can use softmax as well. I will talk about what is softmax. Formula for softmax is nothing but e to the power xi divided by summation of e to the power xi. What is softmax? Don't get into that. I will discuss. When I will talk about all the activation function, I will be talking about those things and you will be able to remember it. That's not a big deal. So here again I'm trying to utilize 1 by 1 plus e to the power minus of x, as you can see. So I will try to send my 0.4 as a x over here. So I will try to send 1 by 1 plus e to the power minus of 0.4, and again I know that like it is going to give me any kind of output in between 0 to 1 itself. Let's suppose it has given me 0.7. So 0.7 is a probability. Let's suppose for the class 1 it is trying to give me like let's suppose it has predicted for class 1, so it has given me probability is equal to 0.3, and for class 2 it is giving me 0.7 hypothetically. Let's try to understand that. So it is trying to give me a wrong probability, I would say, for this and this. So I was expecting class 1, but it has given me what? It has given me class 2 probability, because like I will try to keep my like activation functions over here, and I will try to compare. Now, so this particular entire things is very clumsy. So I will try to take new slides, I would say. So here again, I'm going to draw each and everything. So what we have done and what we are trying to do. So this is a kind of a neural network that we have designed. Fine. So here also I have used sigmoid function e to the power minus of x, and this was nothing but it was basically my input. I can say x1, x2, x3, x4, x5. These are the weights w1, w3, and so on. And again w10, w11, and w12. This will be the output 1 and output 2, output 3 out of this sigmoid. So everywhere we are using sigmoid, everywhere, whatever data we are going to insert. Now this is the final layer, I would say. So this I have said as a input layer. This is called as a hidden layer. So basically hidden layer has been used for the learning. So all the learnings happens over here itself, because here itself it is trying to find out all the permutation combination, and then it is trying to send the data to the next layer, I would say. So here I'm trying to get, let's suppose like our probability is equal to 0.7, right? Probability is equal to 0.7 for maybe a class, I would say a 2, and for class 1 I'm able to get maybe probability is equal to 0.3, because even over here, so as a probabilistic function, so I'm using this. So as a probabilistic function, so I'm trying to use same thing over here as a sigmoid function. So I will tell you that this has been used for the binary class classification. Now it could possible that I am trying to do a multi-class classification. So in multi-class classification, this is not you are supposed to use. There is a function called as SOFT, softmax, and e to the power xi divided by summation of e to the power xi. This is something that we use, and I will talk about this function as well. So what is the output that it try to give you, what kind of a parameter it takes, everything. So as of now, forget about this function. Now, so here what I'm trying to do is, so I'm trying to find out the probability, and let's suppose I was expecting class 1, but it has given me class 2. So I was expecting that if I'm trying to pass this data, so it will try to give me class 1. This was my expectation, hypothetically. This was my expectation, but it has given me a low probability for class 1 and high probability for class 2. Means it will give you one probability, again 1 minus that is equal to a probability for other classes in case of a binary class classification. So I was expecting a high probability for the class 1, but it has given me a probability for the class 2. Now what will happen? So it means that there is some problem between my solution. So if there is some problem between my solution, so what I will do is I will try to find out a loss, or I will try to find out a cost. There is a very thin difference in between a loss and a cost. This is just a word, I would say. This is just a word, I would say. There is a very minor differences which is available in between this and this. I will be talking about that. Don't worry about that. So I will be talking about difference between loss and cost in terms of a one is being used in terms of an individual, and other is being used in terms of a batches. So that's the only differences you will be able to find out, which I will discuss when I will talk about a specific loss function and the cost function. So here you will be able to find out that, okay, so we had a W1, W2, W3, W4. I have taken a random values. I have taken just a very random values, because in a first iteration, when I was trying to send my data, I had no idea about any kind of a weights. any kind of a W or any kind of a biases that we have introduced in between. So maybe I have taken bias is equal to 1 or bias is equal to 0. I had no clue about that. And even as a value of W1, W2, W3, I have taken some kind of a random number. Again, as a value of W10, W11 and W12, I have taken some kind of a random number. But so here, because of those numbers which I have taken in between my network, so I'm able to get maybe a wrong result or maybe a right result. Simple. Because of that, I'm able to get the final output. So because it is something which has been used for doing a calculation and which gets into a final layer, and I'm able to get a final outcome. Now, so what I will do is I will try to find out a loss over here. So again, so in a y is equal to mx plus c, y is equal to mx plus c, I was talking about RMSE loss or MSE loss, I would say, which is nothing but y minus y hat of a square. In case of a regression here, so we can try to find out a binding cross entropy function, or maybe we can try to find out a binding loss in this particular place. So I will try to find out the losses. Losses are nothing but a difference between y and y hat we try to find out. Once I will be able to find out a loss is nothing but you can try to denote that as a error. So again, there are many different kind of a loss which is available. Like there is a L1 loss, there is a L2 loss, there is a hinge loss, there is a HUBER Hoover loss. I will be talking about again 10 plus losses. So I will be talking about a 10 plus activation function, 10 plus I would say a loss function, and I will be talking about a 10 plus optimizer. Because these are something which is a building block of any network that you are going to design in your entire life. So doesn't matter what kind of a neural network architecture, what kind of a complex architecture you are going to study, these will be the building block. Without that, you will not be able to understand anything in any neural network. So I will be talking about 10 plus activation, 10 plus loss function. There are more than 50, 60 which is available, but yes, I will be talking about a widely used and recently developed some of the things. So I will be talking about that in the later stage. So I used to find out a loss. Loss is nothing but it's a difference between y and y hat, I would say, which is denoted as a error. Now, once I will be able to get a error, so again, same principle will be applied. So I was talking about a gradient descent. So in a gradient descent, what we do? In a gradient descent, we always try to optimize. Suppose this is the point. So we always try to fall into a, I would say, a minima. This is what we do. But in that case, we just have a 1e with respect to m and c. Here, you will be able to find out that we have a multiple weights. We have a multiple weights. We don't have only one. We have a 12 weights over here. And if network size is going to increase, if I will try to introduce one more hidden layer, I can introduce it. It depends upon me, I would say. So I can introduce a new hidden layer, again 10 hidden layer in between, and in that way, so weight is going to, in number of weights is going to increase, means number of learnable parameter is going to increase. Now, so in that case, how it is going to train itself one by one. So a very simple example. So I will try to take, I will try to draw an entire neural network again over here so that I will be able to show you the entire flow. So how it is going to take these things, 1, 2, 3, 4, 5. So find x1, x2, x3, x4. Okay. So I had a x1, I had a x2, I had a x3, I had a x4, I had a x5. This is output I am able to get. So let's suppose y hat I am able to get. Then I am trying to compare y and y hat, I would say, which is trying to give me loss, or I would say error, or I would say cost. Now, once I will be able to get a cost, what will be the next step that I am supposed to take? So once I will be able to get a cost, so next step I have to take is a optimize it. So optimize a losses. How I will be able to optimize a loss, and why we are getting a loss, why we are getting this y hat value? Because of a weight. So W1, W2, W3, or like W4, W5, and so on, W10, W11, and W12. 12 that we have taken and the biases that we have taken. So because of that, I would say, so I'm able to receive a y hat. That's the only reason. That's the only reason to get a bias. That's the only reason to get a final outcome. Final, this one is a output. So now I was expecting something else. I got something else. So there is a difference. So based on that, I will try to find out the error. Now what I will do and how I will be able to correct my network. So till this point, this is called as a FC, or this is called as a forward connection. I would say forward connection. So we are trying to move forward from your left hand side to right hand side. We are trying to move, and in a forward network, we are not trying to learn anything. We have just taken our random weights. We have just taken our random biases just to define the relation, because in a very beginning, I didn't have any clue. Even till now, I don't have any idea that what will be the actual weights. I don't have any idea at all. So I have just taken a random weights over there. And based on that, so I'm trying to do something. So here I have introduced, so I have taken a random weights. I have end up introducing a loss over here. Now, how I will be able to decrease a loss? How I will be able to decrease a loss? So can I say that if I'm going to change all of my weights that I have taken by some fraction, by some value, so that it is going to define the exact and the correct relation, in that case, I can expect a better value of y hat. I would say I can expect a better prediction result in this particular place. So what is my end goal and what is my end objective? So in a forward propagation, this is called as a forward propagation, or this is called as a forward connection. So in a forward connection, I do nothing except a calculation. Except multiplication with the weights and passing these things into my activation functions, which is available inside my hidden layer, and then my probabilistic function inside my final layer. I don't learn anything. That is not called as a learning. Even in case of a neural network, I just pass a data. Just like we receive a data set, maybe hot and cold or something from our hands, toes, and all those things, and we try to pass a data through the proper channel, through the proper dendroid and exons, into my medulla oblongata. Now my medulla oblongata, based on its previous learning or experience, it tried to establish a relations. And then I used to feel that, okay, I'm feeling hot, I'm feeling cold. In some of the person, you might have seen that some person will not be able to experience hot, cold or something like that, because their neural network are not able to sense, their neural network are not able to learn that property. That's the reason. So some people is insensitive to some of the human feature, I would say. You might have heard about those stories. So here in a forward propagation, I'm just passing a data, that's it, and whatever random data, random weights which I have chosen. Now, once I will try to find out a loss, what I will do, so I'm able to find out a E, means loss, means error. So I have an error, and error with respect to what? Error with respect to many weights, many biases I'm able to find out. So I'm supposed to do what? I'm supposed to find out a D by DW10, D by DW11, D by DW12. I can say like a D by DW0 and 1, 2, 3 and so on. I'm supposed to find out a new value of W. I'm supposed to find out a new value of weights and the biases. So D by I can say, so DB. So DB1, let's suppose all the network is taking every place I'm trying to give a different biases. So D by DB1, D by DB2, D by DB3. So this is what I'm supposed to do. I'm supposed to learn so that it should come to the local minima. It's the same concept. It should come to the local minima. It should fall over here so that error factor will be equal to 0. I'm supposed to do these things in such a way that it will try to affect all the weights which I have taken, all the hard-coded weights, all the random weights that I have taken, and it will be able to change the value. And this is what happens. So after finding a cost or the loss, so I try to pass these things into something called as a optimizer. Optimizer is a mathematical function. Again, OPTI, MI, ZDR. In any network, in any basic neural network, I would say. So optimizer, what optimizer does is, so it tries to perform a backward propagation. So this is called as a backward propagation. So in feed forward, in forward connection, we don't learn anything. So we don't learn anything. We just try to pass this data and we try to calculate. Here we learn. So here we learn. And now what is the meaning of learning over here? So meaning of learning over here is, so with respect to error, meaning of learning is with respect to error. So try to find out a new value of weights and try to find out a new value of biases. That is a meaning of a learning, I would say. So here I'm trying to learn, and in a backward propagation. So how I will be able to learn? I will be able to learn by finding a d by dw, d by dw 11, d by d 12, d by dw 12, d by dw 13, 14, 15, 16, starting from 0, whatever weights which has been given. And with respect to biases, so we first of all, what we used to do is, so let me draw a new diagram over here. So this is a new neural network that I'm trying to draw. So this one is x1, this is x2, this is x3, this is x4, this is x5. So it's completely fine. So what I'm trying to explain you over here is, so I will be able to get an output. Now, based on the output, I will try to find out a loss. Then after finding a loss, I will send my data into optimizer. So this is something called as a forward connection. Or feed forward network. Now, learning never happens. Like I said very clearly that it will not try to learn anything. So it will not learn anything. Learning happens when and where? So optimizer. Optimizer means what? Optimizer means this. So there are a different kind of optimizer. I will be talking about that. Like I said, so that we are going to talk about 10 plus optimizer, 10 plus loss function or cost function, or 10 plus activation function. So almost 30 functions we are going to discuss back to back to understand our different aspects and different things over here. So optimizer, what it does. So suppose we have a W10, W11 and W12 over here. Suppose we have a W0, W1, W2, W3, W4, W5, W6, W7, W8. So on. So again, in a very beginning, so I have taken a very random weights. Random weights means random values, numerical values which I have taken. So I have to change those values because of that value, I'm able to get an output as a y hat, and there is a difference I'm able to observe in between y and y hat. So I have to minimize the differences, means I have to minimize this losses. So I will try to send all the data set inside the optimizer, and optimizer will start optimizing the weights from the backward propagation. So this is called as a backward propagation. So in a backward propagation, it actually learns. In a forward propagation, there is no learning which happens at all. We are just trying to multiply, divide, and pass it into a data, into an activation function, and finally probabilistic function. So it's completely fine. So here, I would say in a backward propagation, so it will start finding out a new value of, I would say, W10, W11, and W2. So first of all, it will try to cover this layer. So first of all, it will try to cover this layer. How, when, and what is the mathematical intuition behind that? I will be talking about that in a very clear term, I would say, by using a differential calculus. So which the slide which I have shown you last time. So in that slide, so I have already given that step by step how it is going to train the weights. And there are many other terms which will come into picture, like a gradient vanishing problem you are going to face, or people used to say that if my network is too depth, so in that case I will not be able to I will not be able to change a more value of the weight which is available far from the backward side. So why we used to say that, why this kind of intuition we used to make, what kind of a network we used to have to design, everything we'll try to understand. So here into a backward direction, so I try to change the weights. So the weights will be, new value will be given by, again, so same thing, d by dw10. There are many factors which will be involved for sure in this particular place. Again, we try to find out DE by DW11. So calculation for DE by DW10, calculation for DE by DW12, everything we will try to understand, or like DE by DW, I would say like a 12. So calculation, I will try to explain you in terms of a mathematics. As of now, just try to understand that we try to find out the new value of a W. Fine. From the backward direction, that is called as a backward propagation. Again, I will try to find out a W0, W1, W2, and all those things in this particular place. Then once I will be able to find out a new weights, again what I will do is I will send a data. Again, I will try to send the data. Because I have found out the value, again I will send the set of the data. Maybe same data set, maybe a different data set. I can try to send. Again, how we send a data, we will be having a discussion even on that. So we try to send our data into a forward direction. Again, we try to perform the same thing, because last time what we have done, we have changed the weight. And now, so it will try to do all those calculations with respect to a new weights. Other things are same. Here, I have used the activation function as a sigmoid activation function, 1 by 1 plus e to the power minus of x. Here, I have used a probability function as a sigmoid probability function, 1 by 1 plus e to the power minus of x. For the binary, I can say classification. Everything is same. Nothing is going to change. The only thing which I have changed, the only thing which is a variable over here is a weights in this particular place, which I'm going to change. Means weight is defining the relations and the biases. If I am trying to train a biases as well, then for sure biases I will try to, like whatever the new value of the biases, my optimizer will try to find out. So optimizer try to find out into a backward propagation. So that will contribute into a next time. So again, I will try to send the data, new data or same data again, or then again it will give me output. Again, I will try to find out the differences. Again, I will try to find out the loss. Again, it will try to optimize. Means again, it will try to do these things into a backward propagation. So again, into a backward propagation, it will try to find out a new value of weights, I would say, and new value of biases. I will keep on doing, I will keep on repeating these things for the multiple times unless and until I'm not able to get a minimum loss, or unless and until I'm not able to feel that below this system is not able to decrease the loss. Below this, why system is not able to decrease the loss? Because beyond certain point, you will not be able to find out any other relations. If system is able to find out all the combination, all the relation, all the permutation combination, beyond that, if system is not able to find out any other permutation combination, for sure, your loss is not going to decrease in that particular situation, in that particular scenario. So this is a basic intuition, I would say, behind a neural network. In a simplest possible way, if I'll try to explain you, it takes an input. There will be a random weights that we use to create. It try to send all those data into the hidden layer. Then through hidden layer, it could possible that there will be a multiple layer. Now, you guys are going to ask me a question that, okay, so you have designed a single hidden layer. Now, again, inside a hidden layer, you are trying to keep again and again only 3 neurons, only this kind of a neuron. So even this kind of a network is possible, I would say. This is completely acceptable and this is completely fine. I can design this kind of a network. I can code it and all of these things. So here we have a input layer. So here we have a input layer, I would say. This is a hidden layer. This is also a hidden layer. This is also a hidden layer. This is also a hidden layer. And this is a output layer. So this is also possible. You can take a multiple hidden layers, I would say, in between. But if you are trying to introduce a multiple hidden layers, means you are trying to introduce more number of relations, as you can see over here. So again, into a backward propagation, when it will try to learn, when it will try to train something, it means it will have to change these many weights, I would say. And in a forward propagation, again, same kind of a calculation which is going to happen. So again, into a backward propagation, same thing. So it will try to give you y hat. Again, you will try to find out the differences between y and y hat, which is nothing but a loss. And then you will try to pass, this loss is nothing but error. You will try to pass loss into a optimizer. And what optimizer does? So optimizer always try to optimize your weights. As simple as that. And this is what it is going to achieve. So it could possible, just like I have designed, it could possible that I can try to take any number of neurons into any number of hidden layers. Again, there is a logic behind that. So whenever we try to design the neural network architecture, so we keep certain things in our mind. It doesn't mean that if we are going to take a more number of hidden layer, so it is going to give me, or it is going to learn my parameter into a better way. And even it doesn't mean that if you are going to take a less number of a parameter or hidden layers, so it is not going to learn. It changes, and we are going to see all those things into a different kind of a network, different kind of models, I would say. So I think this architecture that we are trying to discuss, the architecture that we are trying to talk about is pretty much clear, I would say, to all of you. You all are able to understand this architecture, and you all will be able to implement, I would say, this kind of a architecture that we have discussed. So I'm just going to save all of those things so that in a later stage, if you wanted to take some kind of a references, you can take a references. Okay, so basically whatever we have discussed over here, so as you can see, it's a pretty generic overview of a neural network. So when I say like neural network is trying to understand the relation, so what is the meaning of that? According to a neural network, what weight goes inside, what input goes inside, what is a hidden layer, what is the input, what is the output layer, what is activation, roles of the activation function. As of now, I have just discussed only one activation function, which is a sigmoid activation function. So what is our roles and responsibility of the activation functions, and all those things, all sort of things we have discussed. What is the meaning of a loss? What is the meaning of optimizer? So just a layman meaning of optimizer, layman meaning of loss function we have understood. Now we'll go into a depth of everything, because that is a building block of, I would say, neural network. Now I will try to go for the visual representation of a neural network, I would say. So let's try to go to Google and just try to search for, I think I have already shown you this particular page. So Tensorflow, Playground. So whatever network which I was trying to explain you, whatever network I have designed, so you will be able to find out that there is an input. There is an input x1, x2. There is some pattern that we are trying to take over here, some pattern of the images. So as you can see, we have 2 dots, and then we have taken a pattern of orange and the blue dots over here. Again, this is the horizontal pattern. Previous one was the vertical pattern that we have taken. Now these are the hidden layers. So I can try to increase any number of the input neurons over here. So a Playground has given you just a limitation of 8, but you can try to increase even 80, 800, no one is going to stop you. And as you can see, so here if you will try to observe, so sometime it is like when I'm trying to increase the number of neurons, I would say, so it's a 2, only 2. Suppose if I'm going to make it as a 3, so it is going to take all the permutation combination. If I'm going to increase these things, it is trying to take almost all the permutation combination by default. As you can see, it is trying to take almost all the kind of a variety of the permutation combination by default in this particular places. So every permutation combination is going inside this network. Some of will be deactivated, some of will be activated at some point of a time, like I told you. So every permutation combination it try to consider, but something it try to activate, sometime it try to deactivate. So here it's fine, I will be taking only 2 in this particular place, or if you say so, I'll take 3 as well. Now, so this is only one hidden layer, and this is the output neurons which I'm able to get. So this is the again another hidden layer. So as of now, I have used a 2 hidden layer. As of now, as you can see, we have like this is input, this is input, this is hidden layer, and this is the output layer. This is the output I'm trying to represent into this graphical format. This is a pictorial format. Now, so I can try to increase the number of hidden layer. There won't be any issue, as you can see. And every hidden layer, I can try to take any number of the neurons. Again, neurons, you can try to keep it as a same or different. No one is going to stop you. It depends upon your architecture design. But whenever we try to design any kind of architecture, we always consider a calculation part. So going forward, you will try to learn. You will be able to understand it. As of now, just try to understand the basic of that. Again, so here, so activation functions wise, I was talking about a sigmoid function. So I can try to take a sigmoid function, that is completely fine. I can try to take a sigmoid function. I can try to take a tanh function. I can try to take a ReLU function, or I can try to take a linear function as well. No one is going to stop you. And what is tanh, what is ReLU, what is sigmoid, what is linear? We'll talk about that in our upcoming class. Like I said, so here 4 is given, but in our class, I will talk about a 10. So even the latest development that we have done till this year, last year, So even I'll talk about those activation functions and optimizers in terms of mathematical explanation. So find learning rate. So I think you remember the learning rate. So whenever we try to find out a new weight, so even over here, so every time, suppose we are trying to find out a new weight, weight 10. So weight 10 at time ith is equal to weight 10 I minus 1 minus eta into delta of E of weight 10. So this is the equation, same equation, kind of equation we have discussed. So here I can try to set a value of a eta. So again, there are a many logic behind that one by using a eta. So what eta we should use and how we should use a eta. Again, eta we can consider as a variable parameter as well. So as of now, I'm saying that eta will be a constant. But going forward, I will try to talk about like a momentum based optimizer. So in a momentum based optimizer, or in some of the network, you will be able to find out momentum based optimizer wherever I'm going to use. So you will be able to find out that I'm going to vary a eta value itself. So I'm not going to take a constant eta value. There is some purpose, there is some reason behind that one, which I will be talking about. So here, as you can see, so I'm trying to send a input in this particular place. I have used a learning rate. A regulation, I'll talk about that. L1, L2 regulation rate also I will talk about that. What kind of problem you're trying to solve, classification or regression. I can try to solve clustering problem as well. There is no problem. So encoder decoder is there. Now if I'll try to start executing it, you will be able to see that it has started decreasing a loss. Again, I'm going to start it. Again, let's suppose I'm going to change the activation function. Here you will be able to find out that now train loss, test loss is 0.52. It will start decreasing the loss. Loss means what? Decreasing a loss means what? It is start decreasing the difference between y and y hat. Because if I am able to decrease the difference between y and y hat, then only I can say that I am able to learn. And one more thing, just try to remember. So if I am trying to hover my mouse everywhere, in every thread that you are able to see, so this is called as a weight. And I have not started a training. I have not started my network as of now, but still there is some weight. That's the reason I told you. So in a very beginning, so we used to take some random weight. I don't know the relations, as you can see. So in a final diagram, in this final image, there is no classification it is able to do in a final images. I have taken a random weights everywhere. I have taken a random weight. So system itself will try to take the random weights because as of now I don't know the relations. So system has taken a random weights, I would say, over here. So everywhere I have a random weights. If I'm going to change this weight, I can change it manually. So I can, if I'm going to take this one, you will be able to find out that the entire relations is going to change just because of this random weight which I am trying to change. So entire relations itself is going to change. See, entire relation is going to change, I would say, over here. Now, so again, if I wanted to introduce some kind of a noises, I can introduce some kind of a noises as well. See, I'm trying to introduce a noise over here. So I can try to introduce a noise, and there are many things which can be possible. So which we'll try to learn going forward. So fine, let's try to start training it, and you will be able to see that it is always trying to fall. It is always trying to fall. Just look into this graph. How this graph is trying to fluctuate. It is always trying to fall in such a way that loss will be almost 10 to 0. And as it is progressing towards a loss, you will be able to find out that it is able to take a shape. It is able to take a shape means what? It is able to do a better classification. This is what I'm trying to show you. And you will be able to find out that now weight has changed. All the weights which was there, so it's constantly changing. It's not 0.79. If I'll again hover my mouse after some time, see, it's a 0.80. So it is learning something. It is learning what? It is learning this relationship, and based on this relationship, so it is able to find, or it is able to make a decision. And here you will be able to find out that it is started from here, and then it is trying to go down. It is still trying to go down as much as possible. So it has started from 0.05, not 0.5, 0.5, and now it is coming to 0.08, which is very less in terms of a loss. So training loss and test loss it is trying to give you. And as this loss is going to decrease, I'm able to find out that my data is going to take a shape. My classification is going to take a better shape. And everywhere you will be able to find out that whatever weights, initial weights that we have taken, every weight has changed. Every weight has changed. Somewhere the weight has like a value of the weight has increased. Somewhere it has deactivated as well. Somewhere it has almost faded. Almost faded means there was no relation. That's the reason I told you there is a permutation combination it try to find out. So every permutation combination it try to take. Sometime it deactivates. As you can see, it's almost deactivated. It's almost deactivated. I would say here also it's almost deactivated. So here also it's almost deactivated. So it try to learn the relationship, it try to learn the weight, and it try to deactivate some of the weights. It try to increase the weight depends upon the relationship between my data set, which I'm going to give. Here also I'm trying to give the data. We have a dots, means we have a coordinates we are trying to give. And then we have two classes, one is a blue class, one is the orange class we are trying to give. So this is what it does in terms of a normal neural network. This is the entire learning procedure. So there will be a feed forward, there will be a backward. So in a feed forward, so it always try to send a data. In a backward propagation, so it will always try to optimize, or it will always try to train the weights based on the optimizer, and how optimizer is going to work, what and all things happens in a backend. So I have already uploaded a slide. If you wanted to go through that, so you can try to go through that. So this is the slide which I have uploaded for you. So again, all the mathematical, all the programming things. So here I'm trying to build a neural network without even using any TensorFlow or any Keras or any PyTorch library, without using any kind of a deep learning library. Just by using a simple Python code, I'm trying to create a neural network over here. So that will be the starting point. And again, all the mathematics I have given over here, which I will discuss for sure in your class. So for sure, I will be talking about, let me show you this, what is there inside this one. So if you will try to look into this one, so whatever I was talking about in terms of a backward propagation, in terms of feed forward propagation, so everything is mentioned over here. So everything you will be able to find out in this particular place itself. And here, so as you can see, just by using a raw coding, so I'm trying to design and try to train the network. You will not be able to understand as of now, even if you are going through this, and even if you know Python code. So just wait for the next class where I will talk about these things. Or else you can, if you are able to understand, it's well and good, you can do that. So I was talking about the backward propagation, I was talking about these calculations, and then so here I'm trying to show you that how actually when I'm saying that I'm using optimizer, and optimizer is trying to find out the value of W10, new value of W10, new value of W11, and all those things from the backward to forward in a backward propagation. So how this training happens, I will try to discuss, I'll try to talk about this equation, and then only you will be able to get a very clear picture, and you will be able to get a very clear understanding. Before that, I don't think that you will be able to get a better understanding. So just wait for like this class to happen, and I will be talking about that. Otherwise, I think we have already uploaded our recordings. You can go through our recordings and you will get to know about that if you wanted to complete these things in a fast track. So fine, this is what I had to discuss with you. And again, you can see that I'm trying to send the data for 1,449 epochs. And again, it is sending a data. It means what? Again and again, I'm sending a data. Again, I will send a data based on the weights. It will try to find the y hat. Again, it will try to do a backward propagation. It will try to learn something. So this is what it will try to do into a backward propagation and into a forward propagation, I would say. And this is the basic intuition behind a neural network. Now we are going to learn many kind of a neural network, even in our computer vision part, even in our NLP part, there are very much complex networks are available. So just try to clarify all those concepts, the basic concept. The material is already given to you. Try to read out those materials, I would say, and it will help you out. And again, try to go through the lecture, which will help you out all the time. And then we'll try to look into the coding. So this is it, guys, like from my end from today's class. So now those who have to drop, so they can drop off, and those who have a question, so they can just raise a hand. And yes, please try to avoid asking a stupid question, because after explaining these things, I'm not expecting any kind of a stupid question. So yes, make sure that you ask some kind of a genuine question. And yes. So that will be my at least least expectation. I think we have already answered more than 300 questions in your Q&A session as well. This is what I can see. So fine, I will just start unmuting you guys, and you can start asking few of the question from your end, one by one. Yeah, go ahead.
Hello, sir.
Yeah.
Sir, I want to ask, like, in a neural network, there are various hidden layers.
Yeah.
And these hidden layers do provide the security to our neural network. And what is the reason, like why we put
Why
is
you're
it?
trying to compare these things with the security? What is the meaning of security over here?
Oh, no sir, I am just assuming like why
Why
we
you
use
are assuming? So security means what? What kind of a security you are looking for? Data
like
security?
no sir, no, like it has more layers, so it means more accurate answer I am
No,
thinking
that's the
like.
reason I told you. I have made one statement, if you remember, right? More number of hidden units doesn't mean that so you will be able to get the better outcome, right? So it's again less number of hidden units or less number of hidden layers, or therefore the network doesn't mean that I have a bad network. So it doesn't work in that way. Okay, I think I am able to answer your question. Next one.
So sir,
Hello.
without
Hello,
using
Akshu.
these hidden layers, can we make a neural network?
No, sir. At least one hidden network, one hidden layer should be there, right? Otherwise, what is the meaning of like a network if you're trying to take an input and output?
Okay
Hidden
sir,
layer, at
and
least one is necessary, right?
okay sir, and next question, like in the last final output you are using a loss formula like y minus y predicted.
Yes, yeah. So
And
that
sir,
is loss function is there. There are a different kind of a loss function. So generally, like a binary cross entropy function kind of a things that we generally use. So first of all, you will have to explain what is a binary cross entropy, what loss function we should use in what kind of a situation, and then only you will be able to understand the exact things. In case of a regression, I have given you the formula MSE, right?
yes sir,
1/2 y minus y height square. So that has been
we
used for the calculation inside a. I would say that has been used to calculate all those things in terms of a like a regression problem. Classification, there is a different loss function. I will be talking about that in upcoming classes.
Hello, sir.
Sudhanshu,
You told like in hidden layer, the Sigmoid function act as a normal activation function, but at the output layer, you told like Sigmoid function act as a probabilistic function.
Yes,
So
you will get
actually,
to
it is
know
not
up.
clear.
Yeah, so you will get to know in the future for sure.
Hey, Sudhanshu.
hello,
Sir.
Next question, please.
hello, Sudhanshu.
Those who are trying to make any kind of unnecessary noise, right? So I have an
Hi.
okay, fine. Lower
Akshu,
all the hand.
my question is regarding the activation function that it add the non-linearity to the data. So I believe I have read from somewhere that it will is allow to select the number of neuron in to the next layer as well. Like
Who told you? Who told you?
uh, actually, I believe I'm not means I'm not clear with my
Yeah,
statement that
that's the reason. So that's the reason I have given a statement that many people gets confused with a like a randomization of the data or knowledge share with the data set, and many people gets confused with what activation function actually does and what hidden layer actually does. That's the reason. So I have explained you the roles and responsibility of a hidden layer from my side, and that is basically a fact. If you look and don't try to read out any kind of article because article is being read by like or written by people like me and you who have half of the knowledge, right? Try to read out the papers, right, and try to read out some of the genuine books. You will be able to get a genuine answer, and avoid reading any article in any places, because article is being written by mostly 99% of the article will be written by a people who is having a half knowledge and they have some kind of free time, and they try to just do a time pass just to get a likes and subscribe. That's it.
Hi, sir. I
Hi,
have one
Sudhanshu.
question.
Sudhanshu, I have a question. So you're talking about forward pass and backward propagation, right?
Hi, Sudhanshu.
Okay,
Go ahead with your question, boss.
yeah,
So
what is the question?
right. So what I'm asking is, is there a role played by the activation function when we are doing the backward propagation as well?
Yes, actually, some people used to say that. So there is no role played in a backward propagation of a like there is no role or there is nowhere where activation function is involved into a backward propagation. But I won't agree with that. Why? The reason behind this one is, so when I will try to show you this mathematical equation, so in this mathematical equation, I'm going to derive very clearly that there is a contribution here. So if I will talk about this one, so I will try to tell you very clearly that there is a contribution of a activation functions even into a backward propagation. So here I am trying to use something called as a sigma, or here this one sigma is a notation for an activation function, I would say. And yes, there is a layer by layer contribution which comes into a picture. So wherever you might have studied or you might have read that there is again from the articles, because if you read some books, you will not get this misleading information. So from wherever you have read that there is no role of activation functions into a backward propagation, that information is, I would say, incorrect. I think you got your answer.
Yeah.
Hello.
So,
Hi,
Sudhanshu,
Sudhanshu.
I have not referred it from anywhere that I.
Okay, next question, please.
Hi, Sudhanshu. This is Lakshay. I would like to understand, I'm not able to get the intuition, how passing the output of one layer of neurons to the next layer of neurons for further processing will help us to build our model better.
So try to go through a lecture again, Lakshya, and then try to attend all the further lectures. You will get to know. Don't worry. Yeah.
Hello.
Hey,
Yeah, hi,
Sudhanshu.
Sudhanshu, I have one question.
Yeah.
Is it a loss function is same as in machine learning, that error rate like RMSE, MSE for like same?
So basically, loss function is a generic function. So sometimes we use a same kind of a loss function into machine learning as well as into a deep learning. But in deep learning, so you will be able to find out a few more loss functions over here. And yes, you can use a similar kind of a loss function even into a machine learning. That is possible. So loss function is a separate independent function, I would say. There is nothing related to a machine learning or deep learning. Generally, people think that, okay, so I will be able to use Sigmoid only into a deep learning. I will be able to use hypertangent, all those things only into a deep learning, which is like incorrect information. And it doesn't happen in that way. So even in machine learning, so in a different algorithm, we uses those things. Loss function is basically the main idea and main intuition behind using a loss function is to find out the differences between input and output. That's it. And again, either you can use a machine learning inside a machine learning or deep learning, both is completely fine. So I think I'm able to answer most of the questions, and you are going to repeat the same kind of a question. So I will try to wrap up this class. I will try to conclude this class. Make sure that before coming for the next classes, you try to revise all those things and look into the material that I have shared with you. So at least you will get some kind of idea. And yes, revision is very much important. Unless and until you are not going to revise, you will get confused for sure, because there is lots of new things, new terms that we have discussed. So make sure you do that. And apart from that, so those who wanted to attend a Python classes, I think you are getting a notification. You have a dashboard access for the live like a session, so you can try to attend those things. With that, thank you so much for today's class. And yeah, so try to learn, try to read out as much as possible, because that is the only thing which will clarify your ideas. And instead of going through the articles or something, always look for the genuine authors or genuine books. We will try to upload some deep learning books as well inside your dashboard today itself. Tonight we'll try to upload, because what I think is now you should read out some books. So far so forth, I have not uploaded some books, but yeah, now there is a need of uploading a book. So I'll upload a book. So just try to read out the books, the standard books and papers. So I always suggest people. With that, thank you so much. See you again in a next Saturday, same time. And again on a Thursday, so we have a doctoring session. So with that, have a good night to everyone.